In the last lesson, you learned how to multiply and divide rational expressions. So we're going to move forward in this lesson with adding and subtracting rational expressions. Now, since a rational expression is in a fractional form, all of the skills that you learned to add and subtract fractions back probably in elementary school and middle school still apply. And so if you recall, if we can just do a simple scenario here. If I want to add these two fractions that have a different denominator, we need to get the least common denominator, or the least common multiple for the denominator. So you've heard it probably called an LCM and sometimes an LCD. So either one of them is fine. Now, what you want to do here is find the value that they have in common, the least value that they have in common. And so really what's going on here from a least common multiple standpoint is if you just start doing multiples of each one of these, you got 2, 4, 6, 8, and on and on. And then you have 3, 6, 9, and on and on and on. You can see that the least common multiple between these two is 6. And so if we want to get both of them to have a denominator of 6, we would have to figure out what do I need to multiply times each of them to get the 6. So 3 times 2, and again, if I do something to the denominator, I also have to do that to the numerator, and as well on the other fraction. And so now you have a situation where we have a common denominator, and we can add the numerators. And so that's just a quick refresher from your probably late elementary school mathematics course. Now, that is going to apply to the rational expressions as well, except now instead of dealing with numerical values for least common multiple, we're going to deal with polynomial expressions. And so you can see here in this bolded area it says to find the LCM, factor the expression completely, and then find the product of the prime factors. And so we would want to then take each individual part, the greatest of those, and that would be our least common multiple. So if you like, go ahead and try sample problem number 1, parts A and B, and then you can come back and look at the solutions. We'll start here with a simple factoring of each one of these. So that gives me for 2x plus 4, and then the other factors. Okay, and so for our common multiples, since there's nothing exactly the same between these two, we have to use everything as a common multiple. And so basically our answer would be all of these factors together would represent our least common multiple. Okay, so let's take a look at the next one. So we have 3 separate polynomials here that we're going to try to find the least common multiple for. So again, factor each one of them individually. And so what you see here is we have each of these factored, and so we need to take the greatest power of each one of these as our least common multiple. Now notice there are some commonalities here. So first and foremost, I have x minus 1. That's not given to me anywhere else in the multiples. But I do have x plus 4 here and here. I do not need to count that twice. Counting it once is good enough. And then you notice that we have x minus 2. And so here we have it twice, so our greatest power of x minus 2 is x minus 2 squared. So we actually have to count both of those from our prime factorization, and that's ultimately what you did here with some prime factorization. So that would be x minus 2 squared, and that would be our least common multiple between these polynomial functions. Now, understanding this process of finding the least common multiple between polynomials is extremely important, because that's what you're going to be doing whenever you're dealing with the rational expressions and the denominators are polynomial functions. So make sure that you really understand this well before we move forward into the actual adding and subtracting part.